Here are some examples from the day 65 assignment. In this example, here they say that you're rolling two number cubes at the same time. Let x be the random variable that represents the absolute value of the difference of the numbers rolled. So absolute value means positive, difference means subtract. So let's do a table here so that we can illustrate what it is that we're talking about. A number cube has 6 numbers. So let's say here we have number cube 1, like the first number cube is 1, 2, 3, 4, 5, 6. Those are the possibilities that you can roll. And on the second number cube, also 1, 2, 3, 4, 5, 6. And at each intersection, what I'll write is the absolute value of the difference, which there's a trick for this. You can just come across, since 1 minus 1 is 0, 2 minus 2 is 0, 0, zeros go across diagonally, and then as you go away from the zeros, it's just 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4. 1, 2, 1, 2, 3. 1, 2, 3, 1, 2, 1, 2, 3, 4, 1, 1, 2, 3, 4, 5. So, what are the possible values? Well, the only numbers that we see in green are 0, 1, 2, 3, 4, and 5. Okay, then complete this table. So they want the probability of getting each one. So I have a little bit of experience with this. So there's 36 possibilities. So, and for instance, for the zeros, there's 6 of them. So 6 out of 36 should be 1 over 6, but they want you to leave the denominator as 36. So this will be 6 out of 36. The ones are the ones that have the most. For the ones, there's 10 out of 36 are ones. Then for the twos, we have, is it 6 also? 6 out of 36? Then for the, let's see, for the twos, there was 8 out of 36. The threes were 6 out of 36 are threes. The fours are 4 out of 36. And the fives, there are only 2 fives. So 2 out of 36. Is this probability distribution symmetric? Well, if this was symmetric, we would have the highest amount somewhere here in the middle, and then the probability would decrease as we went out to the extremes, and that's not the case. The highest frequency occurs with the number 1, which is off to the left, so this is not symmetric. And the reason is because this is skewed. Well, the tail, if you were to look at a distribution, this would reach its peak here and then tail off towards the right. So since it's right-tailed, it would be skewed right. The tallest bar would occur at 1, with the bars to the right decreasing. And the probability of find the probability of getting a difference greater than 3. Well, greater than 3 is just 4 and 5. If you add those two up, you get 6 out of 36, which should be 1 over 6. They might even take 1 over 6, but I'll just leave it as 6 out of 36. And that's correct. Okay, a trick coin is designed to land heads up with a probability of 80%. You flip the coin 7 times. What's the probability of getting heads? So, what's the probability of getting 0 heads, 1 head, 2 heads, 3 heads, 4 heads, so on and so forth. So if you're not getting heads, you're getting tails. I'm going to do this as a fraction. Instead of as a percent, I'm going to do it as a fraction. And we'll say, this is binomial probability. Since there's only 2 possible outcomes, heads and tails, we'll say that the probability of heads, 80% is 4 out of 5. So the probability of tails is 1 out of 5. And since they have this going from number of heads from 0 to all heads, I'll write the tails first, 1 out of 5, plus 4 out of 5. We've done this earlier this year. We're going to repeat this 7 times. We're going to use Pascal's triangle here. So the 7th row of Pascal's triangle is 1, 7, 21, 35, 35, 21, 7, and 1. And so the tails is going to get attached to the first 7 numbers. So 1 over 5, 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 and 1 over 5. And then the heads gets attached to the last 7. So 4 over 5, 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 4 over 5. So here we have all 7 tails, 6 tails, 5 tails, 4 tails, 3 tails, 2 tails, 1 tail, then 7 heads, 6 heads, 5 heads, 4 heads, 3 heads, 2 heads, 1. And notice how all the exponents add up to 7. Okay, so what we're going to do then is let's do the exponents first. And actually, we can kind of cheat here since we already know that on the denominator we're going to end up with 71/25. That's just that should be 5 to the 7th power. Let me confirm that. 5 power 7 is 78/125. We can just say this is going to all be over 78/125, and then we can just multiply to get the numbers on top. So, like for instance, for the first term, 1 times 1 to the 7th is just 1. So the chances of getting all tails is 1 out of 78/125, plus to get 6 tails and 1 head would be 7 times 1 to the 6th times 4. So that's just going to be 28. And I'll just finish this off. 21 times 16 is 336. Plus the next one, 4 to the 30 equals times 35 is 2240. Plus 4/4 equals times 35, 8960. Then 4 power 5 equals times 21 is plus 21,504. Plus, so we got so far 1, 2, 3, 4, 5, 6. We have 2 left. 4 power 6 equals times 7 is 28,672. Plus, finally, 4 to the 7th power is the 16,384. Okay. 4 power 7, 16,384. 4 power. Okay. So let's fill these. So this is just as far as heads go, this counts as 0 heads, 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6 heads, and then 7 heads. That is the theoretical probability. So 1, 28, 336, 2240, 8960, 21504, 28,672. This appears to be the highest probability, is getting six heads and 1 tail. And then finally 16,384. Okay, so select the correct histogram that shows that. The one that shows 6 heads being the most is this one over here, which is C. See if I can erase this. We can get away with erasing this one here on the top. We've already seen this. So this should be C. What is the probability of getting 3 or 6 heads? If necessary, round to 3 decimal places. Okay, so 3 or 6 would be the 3 heads, which is 2240, plus, okay, that's this one here, that's the 2240, plus the 6 heads, which is 28,672, plus 28,672. So I'll write it up here, 2240 plus 28, because or probability means you're going to add, then divide that by 78125. Divided by 78125. And they said round to the nearest 3 decimal places, so 0.396. 0.396. .396. The probability of getting 4 or more heads. Okay, so 4 or more heads would now be 4 or more. So starting with the 4 then, 8960 plus 21504 plus 28,672 plus 16,384, and then all of that divided by 78,125. So 8960 plus 21504 plus 28,672 plus 16,384 equals divided by 78,125. So we have, and then round to the nearest 3 decimal places, so 0.967. Almost a 97% chance that heads comes out at least 4 times. .967. Which is greater, the probability of getting an even number of heads or the probability of getting an odd number of heads? Okay, so the evens, well, the evens shouldn't count 0 heads, so the evens should be 2, 4, and 6. So let's just do that and see if we get more than 50%. So that would be 336 plus 8960 plus 28,672 equals divided by 78,125, and that gives me 48%. So I have a 48% of getting an even number of heads, which means an odd number is greater. because that's more than 50%. Suppose you flip a coin 7 times and get 7 heads. Based on what you know, would you question whether the coin is fair? Why or why not? If necessary, round. So the probability of getting 7 heads in 7 flips of a fair coin. So a fair coin would be where it's 50%. So that would be 7 times 1/2. If it was a fair coin, if you were to get all 7 heads, it would be 7 1/2 to the 7th power. 2 power of 7 is 128. Is approximately. Do they want that as a decimal? 3 decimal places. So 1 divided by 128. So 0.008 is approximately 0.008. The probability of getting 7 heads and 7 flips with a trick coin is approximately, that was 16,384 divided by 71 or 78,125. So that was 0.210. 0.210. Since getting 7 heads on a trick coin should be easier, I'm guessing they're going to say here, is much or more likely to occur compared to on a fair coin, I would question whether the coin is fair. Let's see did they mark that correct? They did, so we're all set.